So this example asks us to find a basis for the solutions to some system of homogeneous linear equation. Well, let me actually tell you that we have seen these two examples before. They are actually numbers from example 3.5 in lecture 3 earlier. But let me do them again here anyway. So they should be pretty easy now. If I want to find the solution to this system, then I can just go ahead and write the augmented matrix. That's gonna be this guy. When I go reduce it, that's gonna be 1, 0, negative 1, 0, and then 0, 1, 2, 0. So the solution for this guy is that I'm gonna have a free variable. My c is gonna be a free variable here. So the answer is gonna be my c is free, my x is gonna be the same as c, and my y is gonna be negative 2c. Okay, and now my c can be any real number. So notice how I can actually pull the c out. So any vectors of the form c, negative 2c, and c is actually just c times 1, negative 2, and 1, where my c is in R. Now you should see this set is actually just the set of all linear span. It's just the set of all span of this vector 1, negative 2, and 1. So this guy is actually just the span of this vector negative 1 and 2 and 1. So that actually makes this vector here negative 1 and negative 2 and 1 automatically the basis for the solution for this system here. Okay, so let me move on to the next one. I only have one equation to deal with now. So let me just write the augmented matrix anyway. Let me do it the usual old way. My augmented matrix only have one row, and it has two free variables. If I were to write the if I were to write the solution set for this guy, that's gonna be my y and my c are gonna both be a free variable, and then my x is gonna be negative y, negative c, negative y minus c, where my y and c is are real numbers. Now then, something actually tell me, because I have two free variables here, I have my y and my c here, something kind of tells me this thing is gonna have a dimension 2. It's kind of like in the last example, I have one free variable, so my solution space kind of only have one dimension because its basis only have one vector. So, what are the bases for this guy then? Let's see. Notice that vectors in this form, if I separate the y and the c out, anything that can be written in this form is actually just the sum of negative y, and 0, plus negative c and 0 and c, where my y and c are real numbers. So I can rewrite this vector here, negative y, minus y, negative y minus c, and then y and c as a sum of these two vectors. And now I can pull the y out. This guy is gonna be just y times negative 1 and 1 and 0. And the second guy is just c times negative 1 and 0 and 1. La-da! So the solution for this equation is actually just a linear combination of these two vectors, negative 1 and 1 and 0, and negative 1 and 0 and 1. So this guy is actually just the span of negative 1 and 1 and 0, and negative 1 and 0 and 1. Okay. So these two guys are the basis for the solution to this equation here. And as I told you earlier, these numbers are actually from example 3.5 that we see earlier. So let me kind of show you the geometric interpretation of all these as well. Okay, so I have here, this is the same picture that we see from example 3.5. I have two planes. My blue plane, this is x plus y plus c equal to 0. And my, wait a minute, my blue plane, yeah, that's alright. And my green plane, this is the, x plus 2y plus 3c equal to 0. And the orange line is the, intersection of the two. So this is the answer to my part A. Now then, I said that the basis for the orange line, where did I say orange earlier? In any way, the basis for orange line, that should be the vector 1, negative 2, and 1, which is the black vector here. So it's very easy to see that if you scale this black vector here, you're gonna get the orange line. The linear combination, well, linear combination is just the multiple, it's just a scalar multiple of the black vector here. The black vector is gonna be the basis for my orange line. So that's for my part A. Now let me show you my part B. Let me hide all this stuff. For part B, let me hide. So I'm gonna have the blue line, the blue line the blue plane to deal with now. So my two bases that we have earlier is negative 1 and 1 and 0, this guy, and then negative 1 and 0 and 1, this guy. Now let me draw the vector. So then the two black vectors that you see here are gonna form a basis for my blue plane. You can kind of see it kind of fall on the plane. And these two vectors would span the blue plane. Well, it's a little hard to see from here. So you can kind of actually see these two vectors are actually not perpendicular. They are not orthogonal to each other. So that kind of means the basis of a plane, it doesn't have to be perpendicular. And actually, just like I said earlier, there are actually many choices for the basis. So this two is actually just one of the possible choice for the span of the blue plane here.